I'll be explaining a little bit about the bone matrix and going into osteoids, which is the organic part of a bone matrix, which is collagen fibers that resist our pulling forces. And the second component is hydroxyapatite, which is the inorganic part, which is made up of calcium phosphate and known as bone salt that resists forces that try to crush the bone. So the first part is organic, the osteoids, and that's where the maximum amount of stress a material can withstand before breaking when it is pulled or stretched is going to be shown. And so there's 4 different types of cells, the osteogenitor, which turns into osteoblasts, the osteoblasts, which create an environment around them and synthesize collagen and proteins. This also is responsible for building that hydroxyapatite and builds up the bone enzyme. And osteocytes are the matured versions of the osteoblasts. And so this here is represented as a flower, and these osteocytes have arms and branches and can communicate with other osteocytes to maintain our bone health. Then we have osteoclasts, which are derived from monocytes. They are responsible for the bone resorption, the breaking down. And so our bones are constantly being remodeled, building up and broken down. So the osteoplasts I think of as with a B is for building, and the osteoclasts are with a C, which is that crashing bone down. And so I chose to use a sponge to represent the collagen here and the glue that's going to go into all of the different lacunas, which is called as empty spaces within the bone. And that's going to help interplay between the collagen and the hydroxyapatite. So they're going to work together for protecting and building the hardness of the bones and the flexibility of the bones.